Good afternoon to students. Today we will be seeing the unit 4, that is the file systems. So the unit is divided, you can say, into two parts, that is the file system interface and file system implementation. So we will be seeing the first part of the unit today and the concepts related to that, that is the file system interface. So in this file system structure, we will be seeing, or file system interface, we will be seeing today what is the concept of files, that is what are files, how they are stored. Along with that, we will be seeing what are the various access methods which are used to access a file. Then we will be seeing the disk and the directory structure into which the files are organized into. And we will also see what is meant by mounting, that is the file system mounting, how a mount point is created using which files are again accessed. Then we will be seeing what is meant by file sharing, and we will be seeing why protection of files is necessary. Now generally there are various ways in which files are accessed and by different users simultaneously. So that is why the protection for the file system is, or for the files, is very much necessary. So we will be seeing that also as we proceed through the unit. So now what is a file, or what is the concept of file? Now files come into picture because users contain, or users proceed with creating lot of data, and files are the way to store the various types of data as well as information. So users need to continuously store information in the system, and they continuously need to also read it, update it, and again store it back. So that is where the concept of files comes into picture. File is something that is created for the users and by the users. So the user will create a file, store information in that. The information can be anything ranging from data to a program, and the file created needs to be accessed. So it might happen that the user might need to access a file at a later point in time. So that is why he needs to store the file also in the system, so that he can reopen the file later and check it. So that is why the storing of the file also is a very important concept. So that is why the files are generally created to store the information. They are created to store the information. That file is stored in the system, and it will be reaccessed later by the user in case it's required for any modification or any updation, and restored back, or you can say saved back to the system. Now what is a file? How it is actually stored? So it's generally, you can say in terms of this, that it's a contiguous logical address space. So what you mean by contiguous is what we have already seen, that is a single block of memory will be allocated whenever it is stored onto the system instead of several disjoint areas. Block of or chunk of memory is provided directly stored. Let us say name the file as file 1. So here, in case of storing the file into the memory, a contiguous block is allocated to that file. That means a particular chunk of block is allocated to the file, and it is not disjoint in nature. So file 1 will be stored here. Again file 1, there will be a empty area wherein nothing is stored. Again the file 1 might be stored here. So if a file is broken down into this, we call it a non-contiguous memory allocation, which is not the case here. as files need to be intact and stored as a single block. That is why the files are stored as a contiguous logical address space. Now the files can be of various types, and those are created by users for their own benefit and to access them without any problems. So the files can be of data, they can be storing program, or they can be storing any other information also. When it comes to data now, the files can be either it can be numeric, the data can be character, or it can be binary also. It depends on the user of the program or user of the system in what format he requires the file to be and what data he requires. So in that scenario, the data he might store, it might be, some of them might prefer its numeric data, some of them might prefer a binary data, some of them might require a character data also. So the data type, if the file consists of only data, the data can be of various types, and some of those are listed here. Also along with that, the file can be a program file. So in case of a program, as we already know, the program depends on the language. So depending on which language is being used, the program will be depending on that, and the file type will be, or the extension of the file will be by default extension of the program. Then the contents here are generally defined by the file's creator. So whoever is creating a file will define what will be the contents of the file. So if he is using a data, he will define what type of data will be stored in that file. If he is using a program, he will write what type of program it is. So if it's a C program, the format is different. If it's a Java program, file format is different. But all of these can, regardless of whichever language the program is in, it can be still stored in a file. So there are various types. That is why, and some of them can be it can be a text file. So for example, we have various files which are present in the system in the form of text files, and text files don't need any extension as such. You can store any type of program in that, regardless of whether it's a C program, Java program, or Python code, or whichever type of code or program it is, you can store it in a text file directly. Along with that, you can store any type of data also. Then it can be a source file. So the source file could be generally a source code or a source program, and along with that, it will have a particular extension depending on the type of program. So, and along with, after that, these also have another type of file which is called an executable file, or the .exe. So the exe indicates that it's an executable file, and whenever it is executable file is run, a particular software or a program will be run. So generally you see that whenever you want to install a software, you have the extension of that software as .exe, indicating that it's an executable file which has to be executed in order for that software to execute and install on your system. So these are some of the different types which can exist in a system. Now there are various file attributes. So attributes of a file are nothing but characteristics of a file which every file will have. So these characteristics define what type of file it is and what it will be. So some of the file attributes include name. Now this name is the only information which is present in a human readable form. That is the only characteristic of a file which is present in a human readable form. Along with that, you have identifier or ID. Then you have a type, location, size, the protection information about the file, then time, date, and user identification fields also. So what is the identifier for a file? So it's actually a unique tag. Generally, it's a number which identifies the file within the file system. So there will be various types of files and various amount or number of files. That is why the identifier will be a number which will be a unit tag which will be assigned to a file, and through that the OS will be able to identify a particular file. Now the type attribute is needed because there are various types of files present in the system. So it is needed for system which supports different types of files, and depending on the type field, a particular file will be identified as having a particular extension. So if you have all the C programs, they are generally having the type as .c, or you can call them C programs. Similarly for other languages. Then the location here is a pointer to the file location within the system. So it can be anywhere, as files are stored at different, file organization is done in a different way. So the location will be a pointer to that particular file. Then the size field indicates what is the current file size. So every file will have a size. So the size attribute will indicate how much is the capacity of the file, or how much amount of storage is required for that file to be stored on the system. So in case the system has very less amount of storage, whereas the size of the file is very huge, it might not be able to store a file in a particular place. So it might need to be relocated in that scenario. Then the protection attribute, this indicates who controls the reading, writing and executing of the file. So these are nothing but the access privileges. So always on a file there is an attribute saying that it's a read only, write only or executable file. So these attributes, that the protection attribute indicates what are the access privileges for that particular file. Then there is time, data and user identification. So data is required for protection, security and usage monitoring. So this information is present in these attributes. Now whenever files are stored in the system, those are generally stored in a directory structure, and this directory structure is maintained on a disk. Now there can be variations including extended file attributes, which can be a file checksum. So file checksum can be a scenario wherein there is a requirement of checking before opening the file that whether the file is in the original condition or it has been corrupted, wherein in case it is corrupted, it has to be retrieved back. So that is why file checksum might be used, and this entire information about all file attributes is kept in a directory structure. Now, how we have various file attributes which are characteristics for a file. There are various operations which can be performed on the file. Now, file, as we have seen, is already an abstract data type. There are various operations which can be performed on a file. Some of the operations are mentioned here. So firstly, you can create a file, or a file can be created. So there are two steps necessary for creating a file. Firstly, space has to be present in the file system to create a file, and second entry for a new file has to be made in a directory. So that is why whenever you want to create a file or a file needs to be created, firstly a space has to be present on the file system, and a new file entry has to be created for the directory which stores the file. Then you can either write or read to the file, or read a file. So generally to write to a file, a system call is made. Similarly to read a file, also a system call is made. Then to write a file, a system call which is made specifies both the name of the file and the information that has to be returned to the file. So as you are opening the file in the write mode, obviously you need to write some data into the file. So that is why you have to specify not along with the name of the file what information you want to write to the file. So now once you give the name of the file, the system searches for the directory to find the file's location. And once the system finds the location, it writes to the file, and it has to continuously keep a write pointer to the location of the file so that the next write, whenever it takes place, it does not overwrite the existing data. So that pointer has to be maintained at the last write location, the pointer has to be present, indicating that that is the location at which the last write took place. Then to read a file, the system call is needed that specifies the name of the file and where the next block of file should point to. Then there can be another operation which can be performed on the file is repositioning within the file. This is also called a file seek. So the directory is searched for an appropriate entry in this scenario whenever repositioning is required, and the current file position pointer is repositioned to a given value. Now whenever repositioning is done, repositioning within a file need not actually involve any IO operation as such. It is just to say that the file needs to be relocated or repositioned. So the file operation, as I was saying you, it's also called a file seek operation. Similar to this, these are not only the 4 operations which can be performed on a file. There are few more operations. So you can also delete a file. Now whenever you want to delete a file, you have to search for a directory for the named file. So you have to search the directory where the file is actually present. Now after the associated directory entry is found, you have to release, once it is found, all the file space is released so that it can be used by other file and erase the directory entry. So once the file is going to be deleted, there is no need of keeping the directory structure and the file location information still present, because that amount of space could be used to create or store a new file. So in that scenario, the delete operation frees up all the space which is already consumed by the existing file which is going to be deleted. Now delete operation is a bit complex because the parent for a file might be more than one. So in that scenario, path to a particular parent which is asking for a delete is deleted and file is retained as it is in that scenario for the other parent. Similarly, there is a truncate option also wherein you can reduce the size of the file. Then you can open and close the file also by using the open and close command. So this will, open command will search the directory on the disk for the entry of the file. If fi is a file, it will search for the disk entry fi and move the content of the entry to the memory. And close fi will move the content of the entry fi in the memory to the directory structure on the disk. So these are some of the operations which can be performed on the file. So it can be, you can delete, truncate, open and close the file. Along with that, you can also create a file, write and read to the file, as well as reposition within the file. So these are some of the file operations or the operations which are performed or could be performed on a file. These are the various types. So the file types can be of various types. The file types can be many. So that is why there are some of files which are mentioned. So file type can be executable. In this scenario, the extension could be exe, it could be com, it could be bin also in some scenarios, or there might not be any extension also. Whenever there is no extension, it is assumed by default that it's a executable file. Then you have object file. So the object file generally has a extension as .obj or .o also sometimes. The source file, again, source code indicates that it's language dependent. So depending on that, the extension could be C for a .c for a C program, C for a, then you can be Java, then it could be ASM indicating assembly file. Then the file type could be batch. So in case of a batch, it is .bat indicating that it's a batch file. Then text, the file could be a text, it could be word processor, it could be a library file also. Then it could be print or view file. So the extension here would be PostScript, PDF or JPEG. Then it could be archive file also indicating that it's a collection of many files. So it could be, general extension is .zip or .tar nowadays. And the file type could be multimedia. Then in case of multimedia, there are various extensions for a file. The extensions could range from MPEG to .mov, .mp3, .avi and few more also. So depending on the type of multimedia, the extension will vary. Now the file structure. Now the file is structured in various different ways. Firstly, it could be very simple that there is no structure as such defined. So in this scenario, it's a sequence of words or bytes. Or it could be a simple record structure which might be defined. So it will be consisting of lines, and it is determined whether it's a fixed length or variable length. And another structure could be, it could be a complex structure wherein it may be a formatted document, or it could be a relocatable load file. Now what happens is you can simulate the last two with the first method by inserting appropriate control characters. But who decides this, how it is going to happen? So the control is generally with the operating system or the OS, which decides how the file should be structured into. And other scenario might be that the program specifies how the file should be stored. So the control will generally be with the OS, which decides how the file needs to be structured and how it will be stored. So now there are various access methods. Now we have learned how to store a file. So now there are various ways in which we need to access the file also. So one such method is sequential access method or sequential access file method. Here what happens is entire blocks of memory or blocks of file data within the file are arranged in either the ascending or descending order. So here in this scenario, wherever the location, the storage happens, it either happens in ascending or descending order, and the files are stored in that way itself. So whenever a particular access needs to happen, it will happen in sequential order, one by one. But it could be either in ascending order or it could be descending order. So if a particular position is read, then if the pointer needs to go back to the first position, it has to go to entire location again. So there are two operations which can be performed here. Go to the next pointer or go back to the start of the file, or indicating reset. So this is just showing the pseudocode of the various access methods, how the particular access happened. Along with that, it is showing that there is one more access method which is possible in which the file could be accessed. That is the direct access. So direct access is generally used for random access of the file. So whenever the file needs to be accessed in a random manner, what is used is the direct access. Here what happens is whenever sequential access was present, it access the file with respect to the key sequentially. That is in order. In direct access, file is a fixed length logical words, so that is why it will search with key but in a random order. So that is why whenever if you want to search a file directly in random order, the direct access will be the much more preferred method, due to which access of a file will be much more faster. So for example, if you see, you can say that if you want to search a record for all of the employees, if you are searching the record for employee 36, and let us say there are 1,000 records in or 1,000 employees, and so you have 1,000 records. So if you are searching for a record of an employee 36 right now, and if you want to find the record for employee 200, then if you go by direct access, directly you can go to the record for the employee 200. If you want to go to the record to employee 200 using sequential access, you have to go individually one by one. So that is from 36, if you are searching, you need to go to 36, 37, 38, so on up till 200 to reach the employee record 200. Whereas in direct access, you can do it directly, as it allows the access in random order. So that is why the direct access will be a much more preferred method in this scenario, and it will be much more faster compared to sequential access in this example. So this is just the comparison showing how the actual commands are executed in case of sequential access as well as direct access. So if the current pointer needs to be made 0 in sequential access, it is generally done with reset command. Then read next is done in sequential access, whereas in direct access, the current pointer needs to be read, and current pointer is incremented by 1 to point to the next location. Then right next is for sequential access. In case of direct access, the write command uses the write to the current pointer, and then it is incremented by 1 to point to the next location. Now, as I was telling you, that the files are generally stored in a directory structure. So there is a directory which will be which will be which will be pointing to a particular file. So all the files you can see are collection of are collected in the within the system, and they are, whenever they are present in the system, they are accessed through the directory. So directory is a collection of nodes containing information about all the files. So you can see here there is a directory and it is pointing to a particular file. And both the files as well as the directory structure are residing on the disk, and whenever access needs to happen to a file, generally file will be be pointed to by a directory. So generally every time access needs to happen, it generally happens through the directory and then to the actual file. And there are various layers in which, or various methods in which directories are arranged. It could be a single directory method, or the files are arranged as single directory. It could be a two-level directory structure, or it could be tree-structured directory system also. So these all different directory structures which we will see in the next class. So as I was telling you, there are various directory structures which we will see in the next class. So today what we have seen is what is the file concept and the different access methods. We have seen what is the concept of file, how it is created, how it is, why it is created, how it is created, and how it can be stored. Along with that, we have seen some of the concepts of how the files are. There are different files types which can be stored and retrieved, but they need to be stored in a particular manner. And along with that, we have seen today the access methods which are present for a file. So there are two access methods which we have seen, that is the sequential access and the direct access method, and the disk and directory structure which we will see in the next class.